Hey, next part, wave problems. So we have some wave equations here. So distance equals velocity times time. Velocity equals wavelength times frequency. That weird thing is lambda. It's a Greek letter that looks kind of like a person bent over, okay? Lambda. So V equals lambda times F. Yeah, it's also written F times lambda. Whatever, okay? V means velocity. Same velocity as over here. Ha! That's confusing. Good luck. And lambda means wavelength, how long the wave is. And frequency means, or F means frequency. Frequency is how many waves per second. Yes, how many waves pass per second. T means period. It's a period of time. That's why it's a T, but it's a capital T because it's the amount of time it takes for one wavelength to pass. And so mathematically, the period T equals 1 divided by frequency, F. Or, like I have written over here, so frequency equals 1 divided by period, capital T, period similarly equals 1 divided by frequency. Maybe I should use a pointer instead of the erase thing. Okay, so here I'm going to go over just like some example equations. So formulas, distance, velocity, and time related with that triangle of destiny, and velocity, frequency, and wavelength represented here. 3 equations and are related using algebra. A couple things to notice. Frequency is in multiple places. So frequency is up here in this relationship. Frequency is also down here, relating period with frequency. Velocity is in the distance and time equation. It's also over here. So it's kind of like rock, paper, scissors. There's like one thing that's in 2 places. Everything except for period. Capital T, but I guess lowercase t is over there. Anyways, hopefully I didn't confuse you right there. Let's get back and look and see what you have to do on the test. So on the test, hopefully I won't show you any questions, answers here. Okay, so what is given in the following scenario? What is the velocity? Here's your test question, retake. What is the velocity of a sound wave that has a wavelength of 2 meters and a frequency of 175 hertz? So what is given in that following scenario? Okay, you select what's given. What, like when you do a problem in class, what do you put here? What does the problem give you? Next, you're going to be asked, what is the following scenario wanting you to find? So what do you want to find? What is it asking you to solve for? So what would you put here? We have some options there for you. Then what formula should you use? So what formula should you use? There's some options. What are the work and answers? Okay, so you've done this many times before. At least hopefully you have. So over on the wave calculation practice, here's some examples. So what is the velocity of tsunami? Yeah, wait a second. Is that the same question? No. Okay, cool. Sweet. What am I doing? Clicking everywhere. Okay, so we have how much time will it take? Yada, yada, yada. What is the wavelength, frequency? Okay, so you have some, like, this is kind of what, here's what we're given in this problem. Here's what we want to find. We want to find the wavelength. And then the formula is velocity divided by frequency. Here's the work and the answer, yada, yada. You just plug the stuff in, okay? Here's one for relating distance and velocity to time. So how much time will it take? That's what this question's wanting you to find. You're given 800 meters and 343 meters per second. So those are our givens. The distance and the velocity. Our formula is distance divided by velocity. Oh, your formula should include the variables that you're given, generally. Yeah, okay. And then your work should just input your givens into the formula. It should all line up. Okay, so good luck. I think that's enough strategies to give you, not tricks, strategies. Okay, have a good one. Good luck. You can do this.